Okay, hello everyone. We are discussing application of Fourier transform. In this class, we are going to discuss somewhat different type of problem as compared with the previous two. So, in our previous class, we have been discussed mm, heat flow along a substance. This one, find the solution of heat equation using Fourier transform. And before that, we discussed to find the solution of one-dimensional wave equation. In these two numericals, here initial value condition is given that y(x0) equal to fx. Here y(x0) t equal to 0 value is given, and here also same u(x0) is given. But suppose in a problem u0t is given, then how we are going to be solve those kind of problems? So for those kind of problems, we have to use Fourier cosine or sine transform. Here I written clearly, in some situations Fourier transform may not be used. Then in these cases, we have to use Fourier cosine or sine transform. So what type of numericals? For example, if ux0, here 0t means x equal to 0, t is given in a problem, then we have to use Fourier transform fs, that is a Fourier sine transform, to remove del square u by del x square from differential equation. But if del by del x of ux0 or u0t, here x equal to 0, will be given, then we have to use Fourier cosine transform to remove del square by del x square u. Okay, so let's start with a problem. So here this is the problem, that the temperature distribution uxt in a thin homogeneous semi-infinite bar, or you just write homogeneous bar. Okay, homogeneous bar having a particular length, satisfy the initial boundary value problem is given by this one, that is your ux0 equal to fx and u0t equal to 0. See, here ux0 is given and u0t also given. That means x equal to 0 at a particular time is 0. Find the temperature distribution uxt for t greater than 0, where x 0 to infinity, less than infinity. Okay. So okay, you just write semi-infinite. Okay, no problem. Just write, because a very long thin homogeneous infinite bar like this, suppose like this, a thin infinite long where is there. So temperature distribution is given by uxt, temperature distribution is your uxt, and the so called differential equation is your del u by del t equal to c square del square u by del x square. So here the same differential equation as we have been discussed in our previous problem, that distribution of heat equation using Fourier transform, that is your del u by del t. Here you use the function of xt, c square del square u by del x square, c square del square u by del x square. Here u and here u is the function of xt. You can write itself, right? So this is the differential equation for a long thin wire, and the initial value condition is given that ux0 is given, and also u0t equal to 0 is given. So if this is given, then here for this case we have to apply Fourier sine transform. Okay, how we are going to be solved, that we are going to discuss step by step. Okay, so let's start. So the given differential equation is this one, and these are the two boundary conditions. So first we have to write the given differential equation is, just write this way, del u, which is the function of xt by del t, equal to del square by del x square, c square is there, c square into del square by del x square u, which is the function of xt. Here u is the small u. Okay, let this is your equation number 1. Okay, so here you have to write, as this initial value condition is given, so we have to apply Fourier sine transform on this equation number 1. So you have to write, as initial condition u 0t is given, so that Fourier sine transform is applied on equation number 1. Okay, here you just write for Fourier sine transform as capital Fs. S is in the subscript. Okay, as initial condition this one is given, so that Fourier transform Fs is applied on equation number 1, we get so you just apply on equation number 1 Fs Fourier sine transform applied left hand side, del small u, which is the function of del t, function of xt by del t, equal to Fourier sine transform applied on right hand side of the equation number 1, c square into del square by del x square of small u, which is the function of xt, right? That implies 2 by pi root over 0 to infinity, this one, del by del t of u xt, function of u xt, into sine omega t dt dx, sine omega x dx, okay, is equal to c square is the constant taken outside, 2 by pi root over 0 to infinity del square by del x square u, which is the function of xt, into sine omega x dx. Okay, see how it is. We know that suppose we have a function f t, f is a function which is the function of t only. So if we are going to apply Fourier sine transform over ft, it will be written as 2 by pi root over ft sine omega t dt. But here we targeted this x, that means Fourier sine transform will be applied on this x variable. So what we have to write, sine omega x into dx. Okay, if we are going to target this variable, we have to write sine omega t dt. So if we are going to target the Fourier transform over x, then we have to write sine omega x dx. Okay, now that implies, here you can see that Fourier sine transform applied on x, and the integration itself with respect to x. So del by del t can be taken outside. So this can be written as del by del t of 2 by pi root over 0 to infinity u, which is the function of xt, sine omega x dx, which will be equal to c square 2 by pi root over 0 to infinity del square by del x square u, which is the function of xt, into sine omega x dx. Okay, now the left hand side will be written as del by del t of, this is nothing but the Fourier sine transform. Okay, put it the bracket over here. That means this much value we can write capital Fs omega t. Why? Here you can see that the Fourier transform applied on the x variable uxt sine omega x dx. So which variable it will be applied, that variable will be omega t, because we know that Fourier transform of ft will be written as what? Capital F s subscript s omega. This is nothing but capital Fs omega. So similarly here it will be capital Fs omega t will be equal to c square c. This much value is nothing but Fourier sine transform upon the derivative, double derivative. This value will be this much value. This much value will be written as minus omega square Fourier sine transform omega t plus 2 by pi root over omega u, instead of x we have tried 0 t. Okay, because previously we have been discussed that Fourier sine transform of first derivative of a function, here this function is the function of t, will be equal to minus omega Fourier cosine transform of omega, and Fourier sine transform of double derivative of a function f, which is the function of t, will be nothing but 2 by pi root over omega small f0 minus omega square Fourier sine transform of omega. Okay, here t is there, so we written Fs omega. So that means Fourier transform applied on the t variable, but here in this case this is u double dash. Okay, this is the second derivative of u, which is the function of xt, but here the second derivative of function f, which is the function of only t. So here Fourier sine transform applied on the variable of t. So here Fourier sine transform applied on x. Okay, so what we have to write? See, this term I have written faster. So minus omega square Fs omega minus omega square Fs omega. That means instead of x we have to write omega, and t is there t, right? And the second term is your 2 by pi root over omega into that function small ft is there the function, so f small f0. So here u xt small u xt is the function, so instead of x we have to write 0, because Fourier transform sine transform applied on the x variable. Okay, then so then let this is the equation number your 2. Let this is your equation number 2. Now we are going to consider our initial value condition. Okay, as per initial value condition, next page we have to move. As per initial value condition, initial value condition u0t equal to 0. It is already given in the question. This one u0t is equal to 0. So this value already given in the question. So in your equation number 2, here u0t one term is there, so this whole term will be 0. Then equation number 2 will be, so same thing you have to write u0t is equal to 0. Hence equation number 2 will be That implies del by del t of capital Fs omega t will be equal to minus c square omega square capital Fs omega t, because the second term will be 0 as per the initial value condition. This term will be 0, so this value equal to this one. Okay, so that implies, taken this side to left hand side, we have to write del by del t of capital Fs, put it in the bracket, it will be better, omega t plus c square omega square capital Fs omega t equal to 0. So this is a second order differential equation like this, sorry, first order differential equation, and that is your like this, dy by dx plus m y equal to 0. Okay, so the general solution of this equation, how we can estimate, here you can see dy by dx equal to minus my, and dy by y will be equal to minus m dx, and so take by integrating both the side, this will be ln y will be equal to minus m into x plus ln some factor, some constant factor. So here taken this ln a can be taken left hand side, it will be ln y by a equal to minus mx, and y by a will be equal to e to the minus mx, and y will be equal to a e to the power minus mx. So if I am going to compare this equation with this one, so here instead of m, what we have to write, c square omega square, right? And instead of y, what we have to write, capital Fs omega t. So the general solution of this equation will be capital Fs omega t will be equal to a into some constant a e to the power, here instead of m we have to write c square omega square, so minus c square omega square into t. So here x is there, here t is there, so t. Okay, so this will be the general solution of this equation number 1. So I suggest you can write this one, these steps somewhere in your note, but here I am going to write directly that the solution of this equation number 1, this equation, the above equation, or put it this one, equation number 3, the solution of this equation number 3 will be this one. Okay, so here you can see a is nothing but c square omega square, so a is the function of omega, so I can write a function of omega into e to the minus c square omega square t. Okay, directly I am going to write. So these steps you know very well, so no need to write here in your note, you can write somewhere in the note. Okay, so I am going to erase all the things, I am going to write this one. Okay, so the general solution of equation number 3 will be the solution of equation number 3 will be capital Fs omega t will be equal to capital A, which is a function of omega, into e to the power minus c square omega square t. Okay, let this is your equation number 4. Okay. Now we are going to consider at t equal to 0 what will be the value of equation number 4. At t equal to 0, the equation number 4 will be capital Fs omega 0 equal to a omega, because e to the power 0 will be 1. So here we found that Fs omega 0 equal to a omega Let this is your equation number 5. Okay, so in your equation number 4, which is the general solution of equation number 3, instead of a omega I can write fs omega 0. Okay, so hence equation number 4 will be, hence equation number 4 will be fs omega t will be equal to capital Fs omega 0 into e to the minus c square omega square t. This is the modified general solution of the equation number 3. Let this is your equation number 6. Now we are going to consider another initial value condition. Now consider another initial value condition, that is your ux0 equal to fx. It is given in the question itself, right? Here it is given ux0 equal to fx, it is given in the question, so we considered here. Now we are going to apply Fourier sine transform on this equation. Now apply Fourier transform on above equation. So that implies Fourier transform is applied over left hand side, ux0 equal to Fourier transform is applied on fx. So here this Fourier transform, whenever it will apply on the variable of x. Okay, so directly I can write this one, fs omega 0 is equal to, this will be your fs omega. Okay, let this fs omega equal to capital G omega. Let, okay, so let this is your equation number 7. Now here you can see that in your equation number 6 one term is fs omega 0 is there, so instead of fs omega 0 we can write G omega. Okay, put 7 in equation number 6, we get, put 7 in 6, we get that implies your capital Fs omega t. Okay, this one capital Fs omega t is equal to, instead of Fs omega 0 we can write capital G omega into e to the minus c square omega square t. So this is your latest general solution of this equation number 3 by using two initial value conditions. Okay, so let this is your equation number 8. This one is your 7. Let this is your equation number 8. Here you can see left hand side Fourier sine transform is there. So if I am going to apply inverse Fourier sine transform on this equation number 8, the left hand side will become to the original one, right? Okay, so the here you can see from where we got fs omega t. Here you can see fs omega t is nothing but Fourier sine transform applied on uxt. Okay, so if I am going to apply inverse Fourier transform of this one, fs omega t, capital Fs omega t, then it will be come back to its original one, small uxt. Okay, what we intend to find out as per the question. Now apply this one, inverse Fourier sine transform on equation number 8, we get, that implies inverse Fourier sine transform applied on left hand side fs omega t equal to inverse Fourier sine transform applied on right hand side, that is your G omega into e to the minus c square omega square t. right? So that implies here, as I told, that inverse Fourier transform, sine transform of this one is nothing but your small u xt, okay, and inverse Fourier transform of this one will be written as 2 by pi root over into 0 to infinity g omega into e to the minus c square omega square t into sine omega x into d omega. So this is our required solution of the given differential equation by using two initial value conditions. Okay, so again I am going to be recall you one thing, that here you can see that if I have a function ft, the Fourier sine transform is nothing but capital Fs omega, which will be 2 by pi root over 0 to infinity ft sine omega t dt. So this Fourier transform is applied on the variable of t. So if I am going to put inverse Fourier transform, inverse Fourier sine transform on this, then I can get small ft. Okay, so this will be written as inverse Fourier transform. If you will be applied on this Fs omega, this will be written as 2 by pi root over minus 0 to infinity capital Fs omega sine omega t into d omega. Okay, same thing it has been written, but in our case it is sine omega x. So for inverse Fourier transform, it will be sine omega x into dx. Okay, at the time of Fourier sine transform, we written sine omega x dx. So obviously for the inverse Fourier sine transform, it will be sine omega x into d omega, this one. So this is the final answer, or you can say solution of this given problem. So I suggest watch carefully, write down the note, and ready for the next class. Next class we are going to discuss similar type of problem. Okay, so thank you so much for watching this video. Thank you.